Okay. Always an adventure in technology up here. Before we get started on note stuff, it is time to have our second midterm. I'm sorry to say. I'm sure you're as thrilled about taking the exam as I am about grading it, but it'll be next Thursday. Okay, week from Thursday. So if today's the 3rd, Thursday's the 5th, so the 12th, Thursday the 12th. Be same format as the last exam, covering everything since the last exam. We then have a final exam that is comprehensive. It'll cover everything for the whole semester. Some people find the final much easier because it tends to focus more on the big, broad concepts, especially if you've been in class all the time and paying attention and kept up with the notes at home if you're taking it online. The final tends to go well for people that have been diligent throughout the semester. That'll be a few weeks from now. So next week, second midterm, covering everything since the last midterm through whatever we get through next Tuesday. Same format. All right. So last class we were talking about fracking, and we went through some of these terms, but I thought I would review them quickly again because we're going to get into kind of the details about fracking, probably more about fracking than you ever knew or wanted to know. But since it is a topic that's going to keep coming up in both the news, politics, it's worth having a real understanding, a real background on, so that you can make some informed decisions. So, a few terms. Now, some of these terms we're going to use a little later in the semester with some other chapters, but these are especially important for understanding fracking. First one is porosity. It's just what is the percentage of openings in a rock? Now, if you look at rocks, if you go over there and grab those rocks and pick them up, you feel how heavy they are. They don't seem like they have a lot of open space in them, but you'd be surprised. Igneous rocks typically don't have much at all. Those are rocks that form from magma. The only porosity you get in igneous rocks are some bubbles from gas that was in the magma, or perhaps fractures or breaks that happened afterwards. But the rocks themselves are really dense, not much porosity at all. Real clean sandstones that form from like beach sand actually have a lot of porosity, about 25%. If you pour water or some sort of liquid on top of a sandstone, you can actually watch it soak right in, just like you could a beach sand. But that only refers to the percent of void spaces. So think of a rock, and then think about a big bubble here and a big bubble here, okay? That rock could have a lot of pores, right? A lot of porosity, because it has these big bubbles. But those pores aren't connected in any way. So it'd be really hard for a gas or water to flow through it. That leads us to the second term called permeability. Permeability refers to how easy it is for liquids and gases to move through rocks that have pores. So to have a permeable rock, you not only need pores, but the pores have to be connected so that this material can travel from one pore to the other. So it's possible to have a porous rock that's not permeable if those pores aren't connected. So porosity, it's just the percentage of openings. It has no bearing on whether stuff can actually move between the pores. Permeability refers to the ease in which gases or liquids can move from one pore to the next. If we're talking about oil and gas, we want a porous rock because we want oil and gas to be able to move through the rock into our drill hole where we can suck it out of the ground and make money on it. So we want permeable rocks. this actually plays into fracking as well. It's called tensional strength. And it's this idea that we talked about earlier that rocks are much weaker under tension than they are under compression. It's fairly easy to pry a rock apart than it is to beat it into submission. And we use that in fracking too, because what we want to do in fracking is break the rock so that oil and gas can move through a rock that now has enhanced permeability. We want to make it more permeable by breaking it. That's what fracking does. And if we can play off this fact that rocks are not very strong under tension, if we can figure out a way to pry them apart deep down beneath the earth, that makes it easier for us to break it. And that's what fracking is really based on, is we're going to find a way to inject rock into small pre-existing cracks in the deep rock and pry it apart. And in doing so, we create fractures that allow oil and gas to more efficiently flow into our drill holes. The other thing is that some fractures, in fact all fractures, are easier to continue breaking than they are to start breaking. Or another way to think about it is that it's easier to continue to break a rock that's already broken. I used the example last class of a windshield. If you go push on your windshield with no cracks in it, it's pretty hard to break it. But if there's a crack already there, and I don't encourage you to do this, but I do it all the time because I'm kind of warped. If you have a crack that's partway across, just push on it with the palm of your hand. You can make that baby go way across because it's already opened. It doesn't take much energy to make it go farther. And that's what we do. So that's what geologists who are involved in fracking do, is they actually look for cracks that already exist in these deep rocks. And I'll tell you how we do that in a few minutes. And then we inject fluid into those cracks to try to open them up more. It's a lot easier than just breaking them from the start. So a lot of these rocks that we're looking at are really old. They've been on Earth tens of millions of years. They've gone through a lot. Most of them are probably at the bottom of the ocean at one point. That's how they formed, from the muck at the bottom of the ocean. Then they got progressively buried by more muck. As they went deeper into the earth, they were heated up. They were squished. Plate tectonics bent them a little bit. Maybe they broke. When they broke, maybe they were able to have groundwater flow through them for a while, and maybe that groundwater deposited some minerals in them and effectively fused them shut with all the new minerals. That happens a lot. If you go hike around and look at rocks, a lot of times you can see old cracks and veins in rock that have new minerals in them. This happens all the time. So what'll happen is, one of these drilling companies will be hired by an oil company, and they'll drill straight down into the ground until they reach the rock unit that they really want to suck oil and gas out of. Then they turn the drill horizontal and they follow that rock unit as far as they can. And while they're drilling, so think about this. So they're drilling, right? And that drilling is chewing up rock. And what happens is rock actually comes out of the drill area. And there'll be a geologist like me sitting there. And what they do is anytime a little piece of rock comes out, they look at it. Make sure they're still in that rock unit. And then they'll look for this mineralization. Oh, there's a little piece of quartz. And then 5 minutes later, oh, there's another piece of quartz. And then they'll be able to go back and it's like, oh, well, we drilled 8 feet during that time. And we know that there's fractures roughly every 8 feet apart or every 6 inches apart or whatever. So they'll have an idea of how the old fractures in the rock are spaced just by looking at these little rock chips that come out. If you get a degree in geology, let's say from here, and you get hired by an oil company, this is likely to be the first job you have. It's called well logging. You sit on a well and you watch mud and rock pieces come out, and you grab them and identify them and note where they came from. And it gives you kind of a picture of what's down underneath the surface. But it's really important because it's like shale, 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 shale. Oh, cool, piece of quartz. That must be where there's a fracture. Shale, 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 shale. Oh, another piece of quartz. That must be where there's another fracture. And so on and so on and so on. So you get an idea of what the rocks look like by what the drill bit is spitting out up on top. So like I said, fracking is not a new thing in one sense, is that we've had this idea for a long time. In fact, back in the 1800s, they tried tossing dynamite down drill holes, which is just a really crappy idea when you've got flammable gas and flammable liquids. Detonating dynamite in this environment might not always be the best idea. And the thing is, dynamite isn't actually very good at it, because dynamite expands, right? That's kind of what it does. It expands violently, so it compresses the rock. And rock is really strong when you compress it. So it actually does a really lousy job of breaking the rock. So we found out that dynamite sucked at doing this. And then somebody figured out, you know, if we pump water into the ground under really high pressure, and a little bit of that water gets into those mineralized old fractures, it can pry them apart and break that rock up pretty well and increase its porosity and permeability. But think about this. Let's say you drill straight down, then you drill horizontally, and then you pump a bunch of high pressure water in there to make cracks, right? Well, in order to get the oil and gas out, you got to get the water out. Okay, you got to suck out all the water that you put in there. Once you suck the water out, what happens to those cracks? It's under a lot of pressure down there, right? So the water opens up the cracks. As soon as the water goes away, what happens to the cracks? They shut back up from all the pressure.
I thought they put sand in the water.
That's what they do. They put a bunch of sand in the water, and that keeps the crack open. So it's more than just high pressurized water, and it's more than just sand and water too. So sand and water make up a huge percentage of it. But then there's a bunch of chemicals that they like to add, and there's lots of fracking fluid companies out there, lots of them. And every fracking fluid company has its own cocktail, basically. They have things to prevent oxidizing of the pipe that goes down. They have chemicals that change the viscosity of the liquid. They have all these chemicals that they add into it to enhance the process. And you have fracking company A, and you have fracking company B, and C and D and E, and they all have their own cocktails of fracking fluid. And what they do is they run around all the drilling companies and say, use our fracking fluid, use our fracking fluid. And it's big money. Do these companies want to tell you what's in their fracking fluid? Why not?
It could be bad, flammable.
Okay, it could be bad, but even let's say it wasn't bad for the environment at all. Let's say everything they put in there was completely fine. Would they still want to tell everybody? So you have a fracking fluid company. You have your special sauce, right? He has a fracking fluid company. So is Jesse. You don't want to tell him, right? Because then he's like, oh, that's a pretty good idea. I'm going to put that in my cocktail too. And then I'm going to... These companies don't want to tell each other what's in it because it's proprietary. That's how they make their money. My special sauce is better than your special sauce. And it's like they run around. I have a niece who works for a fracking fluid company. That's all she does is she goes from oil company to oil company. It's like, use our fracking fluid because it does this, 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 and this. And, you know, this company over here, they don't have this magic elixir in it. So they don't want to tell you. For good reason, right? But what if you're a rancher out here in eastern South Dakota and a company wants to put a well on your property and they want to frack it, of course. Do you want to know what's in it? I would want to know what's in it. What kind of crap because it might not all be there might be some nasty stuff in there, right? So you and pretty much everybody who lives up here who isn't a fracking fluid company wants to know what's in this stuff. So you have this fight going on right now between the fracking fluid companies that say, if you make us disclose our chemicals, you're putting us at a competitive disadvantage with our other competitors. And it's, you know, we can't make money if everybody's stealing our ideas. And yet everybody up on the surface is like, I want to know if you put some carcinogen in this thing that might ultimately get in my groundwater. I should be able to know this, right? So right now there's a real fight, and it's being played out in all these communities all over the country as to whether fracking fluid companies have to disclose what's in it. Yeah?
Well, is there like a regulation of what they can put in that fracking fluid?
Not really. The other thing, and then they take this water out, remember, it's got all this chemical, and then they inject it back into the ground. Okay, so you might think, wow, this could be really nasty, right? You know, you got these people, we don't even know what's in their fracking fluid, and they're injecting this stuff into the ground. First thing you have to realize is, where is this fracking fluid going in the first place? It's going into one of these shale units that have tons of oil and gas, okay? That is a nasty rock unit. You know, you're not going to like drink any water that comes out of this thing. The problem is if the fracking fluid gets spilled before it gets pumped into the ground, or remember I said that the well has to be really well cased or lined so that that fracking fluid can't escape into the shallow rock units, but every once in a while it happens. You want to know what's in there in case it does get into the groundwater. So when it does what it's supposed to, it's really not a big deal because that's nasty crap down there 3 or 4 miles anyway, and you're putting more nasty crap down there with it. And that's not likely to affect us anytime soon. The problem is that something goes wrong and the stuff leaks out in the shallow and gets into the groundwater or shallow fractures. So this is definitely an issue. Should fracking fluid companies have to disclose what their special sauce is? And Texas as a state now, I believe, makes them all disclose. Colorado does not. Individual counties are trying to get them to disclose, but the Colorado Oil and Gas Commission fights them all the time, and there's always lawsuits and always gets hung up. So this is far from being resolved. Okay, so we've talked about this a little bit. We'll get into the details, because in this case, the details, they kind of matter. So prior to about 2000, 20 years ago, remember that we usually just put in vertical wells. We just drilled straight down. Sometimes we'd slant them a little, but pretty much they were drilled straight down. Vertical drilling. But then because of the great economic environment that we had in the 1990s with the stock market, Halliburton, Schlumberger, drilling companies were able to invest money and develop some new technology that's completely revolutionized oil and gas extraction. And these are focused on shales. Shales are a really unique, interesting rock. They're the most abundant rock type that we have on the continent. They're everywhere. Basically, they're deep sea mud. So you think about how big our ocean basins are and all the mud that's accumulating down there. If you go back through time, shales are the rock that formed from all that deep sea muck. Lots of shales on Earth. But shales are not very permeable. In fact, they're considered by most to be impermeable. We think of them as trap rocks. They actually have porosity. That's what's interesting about a shale. They're kind of porous. But there's two things about shales that make them impermeable. One is that a lot of pores are not connected. And the next is that the pores are super tiny. They're so tiny that fluids like water that has a high surface tension or oil that has a high viscosity just can't move in those super fine openings. So we drill down in these shales, and then we turn the drilling horizontally. And it says here we can drill horizontally for hundreds of meters. Hundreds of meters meaning thousands of meters. It can be several miles. It can cut across many claims, many leases. So oil and gas companies might get together and actually drill a single well that goes horizontally through all their different leases. So they team up and pay one driller to drill a well, and then they take the money that originates from the materials coming out and then split that up according to how big each person's lease is. So they drill horizontally, and then there's some young geologist, new geologist, sitting on the well, looking at all these rock chips, trying to figure out how closely spaced the pre-existing fractures are. The wells are sealed. Cased is another word for sealed, usually with high-grade concrete, to keep the fracking fluid and then later the oil and gas from seeping into the shallow rock units that might contain groundwater for the people that live in the area. And then our fracking fluid is pumped down under really high pressure. So it's mostly water. And we're talking a lot. We're talking 5 to 10 million gallons of water required to frack a well. That's an issue. That's a lot of water. And we're talking about fracking millions of wells. So we're talking about trillions of gallons of water. And a lot of this drilling is in the western U.S. where we're semi-arid, and we already have water shortages. Now, it doesn't have to be clean river water, it could be wastewater, but that's typically not done. So it's mostly water, and then sand or bauxite, which is an aluminum oxide. It's basically another kind of sand. About 9.5%. We call this proppant. Props open the fractures once they form. And it's permeable. So you're putting this highly permeable sand and bauxite in the cracks to keep them open, and that allows the oil and gas to flow out really easy. And then there's the sauce. 0.5%. So it's not a lot by percentage, but when you're talking tens of millions of gallons, 0.5% can be quite a lot physically. And I'm going to show you a list in a second of things that are in fracking fluid. You don't have to write them down because some of them are weird, like guar gum, which is also in food, and polyethylene glycol, which is a fancy term for wax, makes things slippery. So yeah, it's quite the, these things are quite the concoctions. All sorts of stuff in there. So the geologist will pay attention to the fractures that are already there, And depending on a lot of things that we're just not going to get into, an oil company might want to frack the rock in a way where you have lots of short, closely spaced fractures. Or maybe they want a slightly different fracturing configuration where they want fewer but longer fractures. And you can do that. You just have to change the viscosity of the fracking fluid. And we do that with different chemicals. So some fracking fluids are good for giving lots of short, stubby, numerous fractures, and some are better for, let's make a few big, long ones. So you've got lots of different companies that work on this. So you've got the oil company. They're the ones, they get the lease, they look for the trap rock, they look for the source rock, they get an idea of what rocks they want to drill into and how much oil and gas might come out. But oil companies don't typically do their own drilling. So they'll hire a drilling company, like Schlumberger or Halliburton, to come in and drill their well. And then they'll hire a fracking company that'll come in. And then that fracking company will get their fracking fluids from one of these many fracking fluid companies. These are all called oil service companies. You got the oil companies, you got your Exxons, Mobils, big companies. My family's oil company is Antelope Energy. They're tiny compared to the other ones. But then they have to hire this company and this company and this company and this company. So there's lots of these service companies. The oil industry is huge. There's lots of different sub-industries other than just, everybody thinks, oh, oil industry, we're talking about Exxon Mobil. We're talking about lots of companies. Like I said, these fluids are typically proprietary. The recipe is secret. There's a big push from the environmental industry, city leaders, basically everybody outside the oil and gas world to tell us what the hell's in this stuff. Most of the stuff that's in fracking fluid is not a problem. A few things are. Won't kid you on that. There's stuff in fracking fluid you don't want to drink. You do not want this leaking into your groundwater. You know, and they'll say, oh, it's just sand and water. Yeah, it is. 99.5% is sand and water. And then there's 0.5% of other stuff. Most of that stuff's fine too. But there's a few things that aren't fine. I personally don't always like throwing my feelings on the matter into these things, but you guys should know what's in this stuff. Everybody should know what's in this stuff. I know it puts companies at a competitive disadvantage, but I think there's ways around that too. You can put together state boards who look into this and don't share the information with other companies. That's not a perfect solution, but there are ways to get at this. You don't have to write this down. In fact, I'd urge you not to. You'll go nuts. So I'm just going to list some of the things that are in fracking fluids. So sometimes we put acids in, and those go in first a lot of times. And what they do is they start to dissolve out some of the mineralization that are in this pre-existing crack so that the fracking fluids can start making their way in there. And then all the fracking fluid does is pry apart a previously open fracture, which we said was pretty easy to do. It's the windshield example. So that's what the whole fracking thing is based on. Sometimes salt is put in to delay the breakdown of other things that we put in fracking fluid that do break down in this. Remember, it's hot down there. It's under pressure. So a lot of times these chemicals might interact with one another, and we really don't want that to happen. Polyacrylamide changes the viscosity and the way it flows. We're pumping this down under high pressure. We want it to go in smoothly. We want it to go in without turbulence, which allows us to pump at a higher rate, higher pressure, and give us more fractures. Ethylene glycol is a wax. What it does is it kind of coats the pipes as it goes down and prevents scaling and accumulations of stuff on the pipes. You want to keep the pipe nice and clear so the fracking fluid can go in easy, come out easy, and then the oil and gas can come out as well without having the pipes clog up. Borate keeps viscosity at a certain level even though temperature is increasing. Glutaraldehyde is a disinfectant, keeps bacteria from interfering with the process. Guar gum, it's actually in food, it's a viscosity agent. Citric acid, it's in food. Vitamin C, put vitamin C down there, prevents corrosion. Isopropanol, it's like a winterizing, keeps stuff from freezing in the shallow areas. And remember, now some of those things, not such a big deal. Other things, yeah, you really don't want to drink it. I don't want to drink polyacrylamide. I don't want to drink isopropanol, that's for sure. Now, if it absolutely does not get into the groundwater, it's probably not a problem. People think, oh, we're pumping this nasty stuff into the ground. Well, we're pumping it into nasty ground. This already has oil and natural gas and all sorts of tar-like stuff. It's nasty. We're just putting a different kind of nasty water in, and it's really deep. And for the most part, not a problem. But if we mess up our drilling and don't case our well properly, this stuff gets into shallow rock units. Okay, is fracking good? Is fracking bad? The answer to is fracking good is yes. The answer is fracking bad? The answer is yes. There's good aspects and bad aspects, just like everything we talk about in this class. If it didn't have any good, we wouldn't do it. The good. We have a growing world population that needs energy. A lot of this growth is occurring in countries that are not well off economically. So it's important that our energy is as cheap as possible, or else the poorest of our brothers and sisters aren't going to have access to it. I think we lose sight of that a lot here in the US. You know, it's like, yeah, I don't mind if stuff's a little more expensive. If it's good for the environment, I'll do it. I can say that because I'm economically privileged. Even you guys don't have much money compared to folks in other parts of the world. You're rich. It's all a matter of perspective. In parts of the world, if you say, you know, I'm going to raise your gas prices, oh, just a penny or two, that's the end of it for them. They don't have it. And then they're going to be doing risky stuff to get energy. Like in India, they're going to be shimmering out on hot power wires trying to hook up their own wires so they can steal electricity because they just can't afford it. So what this does is it provides us some cheaper energy. And if you care about people around the world, you want cheap energy because you want the poorest people on the planet to be able to have things that make their lives better as well. It's really good for us here in the US. I spent a considerable amount of time the last couple of weeks talking about how pathetic our fossil fuel stores are here compared to other parts of the world, and how the countries that have great fossil fuel reserves are countries that are not always on the best political terms with us. being able to frack shales, which the U.S. has a lot of, has increased our natural gas production by way over 50%. That's a lot of energy that we don't have to go elsewhere to get. We can produce that right here. All that money stays here. It's very profitable, which means there's lots of jobs. These are good paying jobs. I'm guessing most of you probably know a person or two in the oil industry. I know some people who at best have a quarter of a brain, and they work for an oil company or an oil service company, and they make way more than I do. And at the end of the day, you think, it's just not right. I mean, I went to college for 9 damn years, and a professor for I don't even want to tell you how long, you know, and Timmy dipshit over there, straight out of high school, gets a job with an oil company, $180,000 a year, driving a truck. And yeah, you guys know them, I know them. These are great jobs. And if you have one of these jobs, you're not giving it up, because if Timmy dipshit isn't driving a truck for an oil company, $180,000 a year, he's working at Best Buy at best, you know, as a stalker. And that's, you know how it works, right? So, yeah. So yeah, these are providing good jobs to a lot of people who normally wouldn't have a good job. And even though I think it makes us all a little jealous at times, it's hard to argue that that's a bad thing. Well, the problem is people screw up. Even these fantastic oil drilling companies like Halliburton and Schlumberger, they have amazing track record for drilling safely, effectively. I mean, it's a fraction of a percent of wells that get screwed up. But when you frack over 1 million wells, a fraction of percent, suddenly you're looking at hundreds of wells, maybe thousands of wells that are messed up. And every messed up well is affecting a few to a lot of people. And there have been areas that have been highly impacted. Pennsylvania was one of the first places that felt the fracking boom in the Marcellus Shale. And, you know, scientists, we get better at stuff as we go on. I always like to say that science always gets us closer to the right answer, not farther away. So as time goes on, we get better at this. But these were the early days of the directional drilling, modern fracking, and they messed up. And they polluted some groundwater. They spilled some of this stuff. They didn't try to. It wasn't intentional. But they did it. And it impacted people in a terrible way. And that's where I have the beef. It's like, okay, you screwed up. I get it. It happens. Now own it and do something about it. But you know what happens, especially here in the U.S. It's like, not my fault. Prove it. And, you know, they have money to hire lots of lawyers. And farmers and ranchers don't. So a lot of times they don't get justice. And that, as a person, as a professor, as a geologist, and as somebody who benefits from the oil company, that really pisses me off. It's wrong. Shouldn't be doing that stuff, especially when these companies make so damn much money. You know, to hold on to your profits, vice grip at the expense of other people. I mean, I believe in capitalism, but I don't believe in treating people in that sort of manner. But that's me. Remember when we talked about radon class periods ago? Remember, radon is a gas that flows through pores and fractures up to the surface. Well, when you frack ground, remember we're looking for pre-existing fractures. And sometimes we can make these fractures go for so far that it actually enhances the amount of radon that makes it to the Earth's surface because it cracks so much of the rock. So fracking can actually increase the percentage of radon that makes it to the Earth's surface. That's a problem I would be particularly concerned with if I lived in fracking country. If I had land that an oil company wanted to put a well on and frack on, I'd probably do a deal with them, but it would include water testing before and after. And if bad things in the water increase by a certain amount, I want to be paid. And I would also do the same with radon. And it wouldn't even be that it has to be the oil company's fault, because it's really hard to prove fault. I would just say, if it increases, you pay. That's just a risk you assume as a rich oil company. Now remember, these rocks exist way down beneath the Earth's surface. They have lots of oil and gas in them. They've been down there a long time. And over time, some of that gas and oil has been able to wiggle its way up to the Earth's surface. And while it wiggles its way up to the Earth's surface, it has to travel through some of those shallow groundwater aquifers. So if you go anywhere that has oil and gas in significant amounts beneath the surface, groundwater up near the surface is likely to have small amounts of oil and gas in it. You might not be able to see it, smell it, taste it. But sometimes you can see, smell it, or taste it, even before any drilling has happened. But when fracking happens and you get lots of fracturing in the rock, more can end up in your groundwater. And if you don't test before and after, you're not going to know. So I'm going to show you some photos. These are real photos. There are places where you can light water on fire because it has so much petroleum in it. Was there always petroleum in that water? Probably some. But if you don't notice it before fracking and suddenly you notice it after, it could be that fracking enhanced it. But if you don't have a set of water samples from before, you can't prove anything, can you? So does this prove anything? No, all it proves is that there's oil and gas in the area and that you don't want to drink that water. Want to drink that? Yeah, that would be really upsetting, especially if this didn't exist before the oil and gas companies came in. Sure, there may have been tiny amounts, maybe not enough to start a damn bonfire in the kitchen. Lighting water just seems weird, right? A lot of this is due to fracking, but it's really difficult to prove it's due to fracking because it probably existed in smaller amounts before. Okay, a few more factoids. I want to paint a nice clear picture for you because with every little step of the process, there's issues to contend with. Like I said earlier, we're talking millions of gallons of water. It's a lot of water. Most of this is going on in the western U.S. where we don't have a lot of water. We compete with each other for water. Ranchers want water, cities want water, wild areas need water, and now we have oil companies coming in who want a lot of water. And when they're done using the water, there's nothing you can do practically with this in any industry. It's not like you can reuse it or reclaim it. This is nasty stuff. They put a bunch of chemicals in it, then they send it into the ground where there's oil and gas. All that crap's in it. So instead of even trying to reclaim it, they drill an even deeper disposal well and pump it way down into the earth to get it as far away from us as possible. If you drive around Greeley, anywhere up here, you'll see these really large, impenetrable fences going up, keep the noise out, keep the light out. This is a 24-hour-a-day operation. It's loud. When they frack a well, it's impressive. When those fractures start going, the whole area just shakes. You can feel it. Just lots of little earthquakes, basically. And it takes a while. This drilling takes time, fracking takes time, setting up all the infrastructure to collect and transport oil and gas that comes out takes time. Building roads into these farmers' fields takes time. Anywhere from 6 months to 2 years from the start of drilling to when you have a nice sort of passively quiet pumping well. Lots of activity. Seismicity, earthquakes during the fracking process. Real chance for earthquakes during the disposal process where it goes really deep into the earth. So when we're talking about these shale units, what we found is that there's oil in it, but the real star of fracking shale units is the natural gas. And natural gas is an interesting energy source. We know burning coal is extremely dirty. Gives off lots of sulfur compounds, lots of CO2. We know burning oil gives off lots of CO2. Natural gas, we get less carbon production as a waste product for the same amount of energy than we do with the other sources. So it's a cleaner fuel. I won't call it clean, because when you burn it, you still get CO2 and some other things. But if you're an environmental type, care about the environment, care about climate change, and you have a choice of coal, oil, or natural gas, you're going to choose natural gas. It's the cleanest of the bunch. Now, folks like me who look to the future, look at what's happening now, already seeing displacement on Earth of populations because of climate change, already seeing what's going on here and elsewhere with growing seasons, with fire seasons, sea level change. These climate change effects are already here, and they're getting expensive. I want to see us move from fossil fuels. The question we have, and that we're not dealing with as a nation, is how do we go from where we are now, 80 to 90% fossil fuels, to something that's not only not going to put carbon in the air, but be cheaper. That's what we need, right? We need a cheaper source. We can't go to a more expensive source. Because one, free market isn't going to really allow it, and two, it only makes the situation for poor people around the world worse. I don't want to see that. So how do we go from where we are now to a cheaper, cleaner form of energy? That's what we don't have a roadmap to, because our politicians want to stay in Washington and fight about whether climate change is even real or not. So we sit there and do nothing. We argue about something that's not a question, rather than really do the hard thing and say, okay, how do we go from here to there? Back in the 60s, 50s, 70s here in the US, we had an energy policy. Government said, this is what our future is with energy. Then it was fossil fuels. You know, it's like, we are going to enhance the production of fossil fuels. We're going to give breaks to the oil and gas companies to produce fossil fuels. That's in our best interest at the time. This was before we knew really much about climate change. And then when climate change became a factor, some people said, okay, we got to change our energy policy. Well, you know how US politics works. You get a bunch of people who are in bed with a bunch of companies, and they're just going to say, we're just going to protect you. Rather than do the right thing, this is what happens. So that's where we are now. We don't have an energy policy. We don't have a good roadmap from where we are now to the future, but anybody who really looks into this says natural gas is probably the bridge. It should be the bridge. What we should do first is we should come up with technology that allows automobiles, electric plants to use natural gas instead of oil. Okay? And while we're doing that, we should be developing some other sources of energy to eventually go to electric or whatever you want to go. We don't have that strategy. But any strategy is likely to involve natural gas, and fracking allows us to have a lot of natural gas. So fracking could actually be a good thing in the long term for the environment if it allows us to go from oil to natural gas to an alternative. But we don't have that all mapped out, and I don't see it happening with today's politics anytime soon. Like I said, most wells have no problems at all. I'd probably change this figure to 99.999% of the time. But I'm going to show you a map in a minute of wells just in Weld County. I may have shown you this earlier, I don't know. But if I haven't, it's impressive. And what you'll see is that even if we only mess up 1% of the time, that's a lot of wells, because there's so many out there. And if you contaminate a groundwater source, depending on where it is, it could be a groundwater source that thousands of people use. Now have to look for another source of water because theirs is polluted. Should we be fracking under cities where lots of people live? If you're an environmentalist, what do you say? Absolutely not. We're going to be impacting water, and all this does is give us more fossil fuels to burn that mess up the climate. If you're a member of the Colorado Oil and Gas Association, what are you going to say? It's safe. It's 99.999% safe. Boulder banned it several years ago. Colorado Oil and Gas Association sued and won, forcing County of Boulder to start giving permits to oil and gas companies for drilling. Boulder, being Boulder, decided they were going to drag their feet as long as humanly possible. They got sued again. I don't know where it is right now. I think they gave a couple of permits to a company they thought was going to go bankrupt. That's what I had heard last. And I think that actually happened. It's just so typically Boulder. Gotta love them. Fighting the man. Even though they're the man sometimes. Okay, this is oil. And what it shows is how much oil in the US is being not only produced per day, but how much is in wells that were fracked. And this goes back from the year 2000 to 2015. So look at 2000. Looks like we're 5.5 million barrels of oil per day. So much of it coming from fracked wells. Fracked wells is in the light blue. Essentially nothing in 2000, right? And 2001, 2, 3, 4, 5, 6, 7. Around 2008 and 9, you see it start to have a greater percentage of oil from fracked wells, right? And then look by the time we hit 2015. This is a pretty new use of technology. Sure, it's got origins that date back to the 40s and even older, but fracking really has only been a big deal for about 10 to 15 years. But now you can see that most of our wells, most of the production is from fracked wells. It works. And look what it's done to the amount of oil that we're producing here in the US. It's essentially doubling it. That's oil we don't have to get from the Middle East. All because of fracking. You can look at this, even if you're a hardcore environmentalist, you can look at this and say, okay, I can see where you would say there's some positive here, right? Yeah, we don't want to be sending our money to countries that want to do us harm in the end. I wouldn't have any problem with this if we actually had a plan to move away from it someday, but right now we don't have that. This is just the sheer number of wells that have been fracked in each state. Texas, 300,000 wells. Start now, count to 300,000. You're going to be here a while, right? Think of how much time, space, money to drill and frack all those wells. That's just Texas. Colorado, 105,000. This was 5-6 years ago. These numbers, I think, have essentially doubled till today. It's a big number, right? Well, what if 1 in every 10,000 wells gets screwed up? That's a pretty small percentage, right? 1 in 10,000. Count to 10,000. You're going to be here a while, right? Just one well. But when we're talking millions, we're talking basically hundreds of messed up wells, messed up groundwater systems, people with explosive water. This is us, okay? This is a map of our region. Every red dot is a producing oil and gas well. What do you notice? Within that maze of wells, basically every square mile of this area has anywhere from 2 to, I think, 8 to 12 wells on it. Where don't you see wells within that? Greeley, that's the hole in the donut, is the city of Greeley. Do you think there's oil and gas underneath us right here? Oh yeah. Do you think oil and gas companies want that? Oh yeah. UNC, we own the mineral and gas rights to everything beneath campus. You think there's a lot of oil and gas under there? Would you be in favor of leasing out UNC's oil and gas rights to an oil company if it would reduce your tuition? It's not a simple question, right? You had to think about it, right? What if it reduced your tuition in half? Suddenly, it's easy to throw stones when it doesn't immediately impact you. But yeah, it's a little more difficult, isn't it? I don't hate fracking. I don't like fracking. To me, it's a two-edged sword. It does some really great things. Think about if your tuition was half the cost. Think of how many more people we could educate. As a professor, I would love that. I would love to see it. In fact, even better, let's cut the UNC population in half and let you all go for free. Even better, right? What if you could go to college for free? Would you say, go ahead? Risk reward, right? This isn't, like I said, I'm not here to tell you what to believe. I'm here to completely F it up for you and make it as difficult as possible. But I want you to think. I don't want you to say, fracking's bad. I can light my water on fire. It's bad. Well, it could pay for your tuition. That could be good. But then some poor folks in town might have messed up water and have to move. That would be bad. It's a two-edged sword, okay? It's pretty damn impressive, isn't it? And all those are probably, all those wells were drilled because they were economically profitable to do so. That's why your friend Timmy's driving a truck for $150,000 a year. It's a lot of money. But this is the consequence. There's an oil and gas. Somebody in my last class, this was her high school down in, I guess down in Denver area. I don't know which one. But yeah, oil and gas facility right next to the football stadium. Because sometimes, you've seen how things are growing around here, right? New subdivisions up all the time. A lot of these oil and gas facilities have been in the ground for 20 or 30 years. Then the city builds up around them. There was an initiative during one of the previous elections, I think it was Proposition 112, and it was put out more by the environmental folks saying that there can be no new oil and gas facilities put in within a half mile of any existing structure that people live or work in. Because we've had some of these things blow up, kill people. But what it didn't really address is, it said the oil and gas companies couldn't build within a half mile of things, but didn't say that the builders had to stay away from the gas facilities. They could build right next to it if it was already there. It was kind of a weird law. It ultimately was defeated. But yeah, it's just one of the things that keeps cropping up. It becomes political football after a little while. This was actually out by the Poudre Learning Center a few years ago. One of the oil and gas facilities had some earthquakes, and then, I don't know if somebody was smoking on site, but it blew up. Now, City Greeley's going to grow, right? You looked at that map 3 or 4 slides ago, right? Is there anywhere Greeley can grow and not come in contact with oil and gas development? No. This is something that we are going to live with around here. It's going to be right there. And there's some dangers associated with it as well. During the floods several years ago, big floods we had in September wiped out Big Thompson Canyon. A lot of oil and gas are fairly close to rivers. Some of them are on floodplains. Those big storage facilities were probably full of oil. Right now, they're probably not full of oil. All that oil probably leaked out and was carried away by the floodwaters. So again, things that we do deep in the earth can have effect here on the Earth's surface as well. This is just a diagram, kind of shows, this one's pretty decent. So you see you drill down until you hit the rock unit that you want to extract oil and gas from. Then you turn the bit horizontally and drill as far as you need to drill. You pump water down. Before you do that, you case the well up in those shallow areas so that the fracking fluid and later the oil and gas doesn't get in and contaminate the shallow aquifer or the deep aquifer. When you pump that water under high pressure, it gets into old fractures, breaks them up. The proppant keeps the fractures open. You suck the water back out, and then the oil and gas follow. And then you dispose that water, in a really deep well somewhere away. But if you drill into a pre-existing fault line, sometimes that fault can start shifting because you weakened it and can create a bunch of earthquakes. And what is earthquake activity going to do to your cased well? Think about this. You case this well, right, to protect it. Now it's shaking and it just breaks it up. And then if you try to frack through that, guess what happens to your fracking fluid? It leaks into all these other units. So, you know, these oil companies certainly assume some risk because they could spend several $1 million on this only to have earthquakes that they created mess up the well so bad that they couldn't use it. So this was just a complete loss of millions of dollars. And then, as I said before, a lot of times what will happen is they will go from the fracking, which is in the kind of the upper right where it says producing well. They got to suck the fracking fluid out in order to get the oil and gas to come later. And then what they usually do is transfer that through a pipeline, sometimes several miles. And it's not unusual if you're driving around here on 34 to see these semis loaded with pipe just stacked on top. A lot of them are going to put in these little pipelines that they can pipe the fracking fluid out. Then they drill a really deep well, in this case all the way down to this lower unit, and they pump the water down there. Try to get it away from us. Why do you want this water away from you? Because it's nasty. Okay, let's end there. Test next Thursday. Go vote if you haven't voted. Enjoy your day, and I'll see you on Thursday.